So welcome everyone to the 7th week of the course. So with that we are now moving into the second half. So in the first 6 weeks we had talked about basic tasks on any language, how do we pre-process the language, how do we deal about its morphology and syntax. Now we will be going to some advanced topics. So in the next 3 weeks, starting this week, we will be talking about semantics. How do we capture semantics? So again, semantics is a very huge topic. We will focus only on very basic and interesting notions that can help you build some important applications and also read some research papers in this field. Later in the last 3 weeks of the course, we will go into various applications. So today we are starting our discussions on semantics. So and we will be talking about two notions, distributional semantics and then lexical semantics. Before going into that, let us see what do I mean by semantics. So in this lecture today, we will give the introduction to the topic of distributional semantics. So as such, when I say semantics, what comes to your mind? In general, so syntax talks about arrangement. Okay, how are the different words arranged in the language? And when I talk about semantics, it immediately we move from arrangement to some sort of meaning domain. So I want to find out what is the meaning of different words, how do they combine together to form the meaning of the larger unit that can be the sentence. That is in general the main field. So if I have to give a definition, I can say that semantics is the study of meaning. That is, what is the relation between symbols and what do they denote. So here, suppose I have the sentence, John told Mary that the train moved out of the station at 3 o'clock. Okay, so sentence in the natural language contains multiple words. We know how to tokenize them and how to find out the morphological tags and maybe also the syntax and different representations. Now what do I mean by saying that now I want to go to semantics? In semantics, I would like to know what all these words themselves mean separately. So what do I mean by John, told, Mary, etc.? So these are all symbols. Now what do they denote? And when they combine together in a sentence, what meaning are they putting? So this is, as I said, very vast field. Lot of different research has happened and is happening. We'll focus on mainly the word meaning. So how do we say what is the meaning of a word? What are different notions? So in general, so when I talk about distributional semantics or any other model that we will cover in this course, we are trying to find out how in general computers can produce such semantic representations. So how machines can interpret some sort of semantics, and that's where the idea of computational comes in here. So computational semantics in general is the study of how we can automate this process of building these semantic representation and also reasoning with them. Okay. So when we talk about the methods, in general there are two different methods. One are based on formal semantics. That is, how do I construct various mathematical models that can tell me what is the relation between various expressions in the language and also relate them to whatever is there in the world. For example, so if you have heard about or read predicate logic, that's what is done in formal semantics. So if I have a sentence like this, John chases a bat, and I want to produce a mathematical structure that denotes the meaning of the sentence. So I'll put that in very logical form. Like I'll say, so first order predicate calculus, I'll say there is an x where x is a bat and John chases the bat. So chase becomes a predicate, and I'll say John chases x, and x I have already defined as a bat. And like that I will define how do I convert my natural language expression to some sort of this logical form, and then I'll also have rules on how do I infer from this logical expressions, how do I deduce one expression into another one, and so on. And this is again a field of formal semantics, and that is something we will not cover in this course. What is something apart from formal semantics that we can see, and where the data a lot of data that we have can help us. And this is where the field of distribution semantics comes in. That is, can I study the statistical patterns of human words usage to extract semantics? So can I see how humans are using different words in their language to find out what is their semantics? And this is what will be the topic of this week. What is the idea of distribution semantics? How do I capture that? And how can I use that for certain meaningful applications? So this field of distribution semantics is mainly built upon this hypothesis of distributional hypothesis that is prevalent from many years. What is the distributional hypothesis? Let us see some famous quotes about this. So as early as in 1953, Wittgenstein said that the meaning of a word is its usage in language. So that is, you can know what is the meaning of a word if you see how it is being used in the language. Okay. Along similar lines, in 1957, Firth said, you know a word by the company it keeps. Now, what do I mean by the company of a word? What are the other words it occurs with in my corpus or in my language? And that tells me about the word. Now going one step further, so what these different quotes are mentioning, that the word meaning, whatever it might be, I do not care about what exactly is the meaning, but whatever it is, it should be reflected in the linguistic distributions. That is the way the word has been used in the language. That will tell me the word meaning. So now Jellick-Harris in 1968 that gave this famous quote that took this idea to one step ahead. That is, words that occur in the same contexts tend to have similar meanings. So now I can talk about two words having similar or different meanings if I can somehow measure their context and capture that. And as I said, two words are having similar meanings if the context in which they occur are very similar. So the idea here is, two words, if they are semantically similar, they tend to have similar distributional patterns. So now that's what we will be doing in this week. How do we capture distributional patterns of words and use that to find out similarity across words? Let's see some other quotes from Jellick-Harris. So he also said that if linguists have to deal with meaning, it can only do so through distributional analysis. And that he said in very early 70s and 80s. And if you see the NLP field right now, so whatever the main methods of semantics are there, they are built upon distributions. So with the recent idea of word embeddings and all. And this is what we will also capture in our in this week of this course. Another very similar sort of quote from Jellick-Harris from his work Distributional Structures. So if we consider a word of morphemes A and B to be more different in meaning than A and C, then we will often find that the distributions of A and B are more different than the distributions of A and C. In other words, difference in meaning correlates with difference of distribution. So what he is saying, suppose I take three different words or morphemes A, B and C, and suppose there is some way I can capture their distribution. So that is how they are occurring in the language. So I have distribution for A, B and C. Now what he is saying, if A and B, the distributions are more different than that of A and C, then what we will find, so what we are saying, A and B are more different than A and C. If the distributions are more different, in the meaning also you will find they are more different. Okay, so you can think of these as, say, take some examples like car as A, and B, C can be automobile, they are quite close, and B can be something like a book. Okay, so here car and automobile are quite similar, and car and book are more different, so they are very different. So if this is what I see in meaning, I will also see something similar in distributions. So what I will find, these two distributions are quite similar, and these two would be quite different. Okay, we will see in this week that how do we capture these distributions and how do we compare them. But this is the basic idea. Now, what is another important thing here? So, the distributions that we are capturing, whatever semantics it is allowing me to handle, it's all differential, not referential. What is the difference between the two terms, differential and referential? So, again, if I look at the same example of these three words, car, book and automobile. So, what do I mean by saying? So, the semantics I am capturing is only differential but not referential. So, I cannot say what is the meaning of car. I am not defining the meaning of car at sort of this concept representation. Okay, this is something I am not doing. So, what I am doing, how similar or how different the two meanings are. So, I am saying A and C, how similar their meanings are or how different their meanings are. So, that is why this is a differential sort of understanding of semantics. So, how different or how similar two different meanings are. I am not talking about some referential meaning in distribution semantics. So, now if we look at, so this was the linguistic perspective. Is there some cognitive perspective also with distribution semantics? So we have this idea that what is the representation of a word, and it is said to be some sort of abstract cognitive structure that I am storing in my brain or somewhere, we do not know, but that is something I gather as I keep on hearing this word or looking or finding this word in more and more context. As I find this word in more and more context, I tend to build some sort of representation about this word. This is the cognitive perspective. And what is some sort of evidence? So for example, when you encounter a new word that you have never heard before, even if you do not know its meaning, you may guess something about this word, what it might be. Okay, so let's take an example. Like I am seeing this word vampy mug. Okay, I have never heard this word before, and now I am seeing this word or hearing this word in this context. He filled the vampy mug with the substance, passed it around, and we all drank some. Okay, so just by looking at the words that are occurring around this word and seeing what other words might occur in place of vampy mug, I can say that this might be some sort of a container, some sort of a glass or something, so which can be used for filling up the substance and passing around. So as I keep on hearing or seeing a word in more and more context, I tend to build some sort of meaning structure about that word. Now suppose I have heard this word in a very different context, like this: we found a little vampy mug sleeping behind the tree. Immediately I will have a different interpretation. I will say, okay, maybe vampy mug is some sort of a small animal. Okay, so this is some sort of intuition behind the cognitive perspective, and why we might think the meaning in terms of the distributions in the language. Now, to capture these distribution and finding semantics from there, the models that are used are called distribution semantic models, and also there is some term called DSM for them. Now, what are these? So, these are various computation models that build contextual semantic representation from my corpus data. So, now what is important here is that I am already given some sort of data, and if more data, generally the better. So, I am given some corpus data on how different words are used in language, and from there I am trying to come up with some semantic model, distribution semantic model, and this will capture the differential aspects of meaning among words. So DSMs are models for semantic representation, and where I capture the semantic content by using a vector. So, for each word we will try to build a different vector that will capture the semantics, and these vectors are obtained via the statistical analysis of the linguistic context of the word. How this word occurs in various contexts will help me to find out its vector representation. And there are some alternative names for this semantics, like corpus based semantics, statistical semantics, geometrical model of meanings, vector semantics, and word space models. And there might be some other prevalent names also, but they capture the same idea, that can I use the distribution of the words to find out the meaning, or at least capture which words are similar than other, which pair of words are similar than other pair of words. So now, so again, so this distribution semantics, when I talk about, what do I mean by the two terms distribution semantics? So when I say distribution, they are the vectors denoting different words, and they are vectors in some high dimensional or low dimensional space, and this space is the semantic space. So I have distributions that are vectors denoting the words in that multidimensional semantic space, and semantic space has dimensions which correspond to various possible context, and these context can be gathered from a corpus. So what I am doing, every word I am denoting in this semantic space, and this is my distribution semantics, and this semantic space is composed of various dimensions that are my context in which I am trying to represent a given word. So let us take this an example. So when I talk about simple vector space model, so that all of you would already be aware of. So this is my two-dimensional plane and it's xy plane, and I can denote different objects. So here there are 2 points that I am denoting, A and B, by their coordinates. So what are so their projection on x-axis and y-axis, that tells me their coordinates, and I can now capture how near two objects are in this space. Analogous to that, now let us think of a semantic space where dimensions are not x and y axis, but they are various context, and can I denote all my words in those dimensions? So here suppose that my dimensions are 2 words, eat and drive, okay, 2 different words, and I am trying to denote 3 words, car, dog and cat, in these dimensions. And what you are seeing here, so this might denote how often a word occurs with this word and this word. The projection will denote that. So you see cat comes quite often with the word eat, similarly dog. Car comes a lot often with drive, but not so much with eat. So you see immediately when you try to put these words in this semantic space, you can capture some similarity, that cat and dog are probably similar, much more similar than cat and car and dog and car. And this is the idea. Can I use different context as my dimensions and represent all my words in those dimensions to give a meaning representation? In general, so here I have shown you only for the dimension that correspond to 2 words, but in general you are allowed to use any number of dimensions. So you can use any number of words that you want. So you might have a representation like that. So I can say cat is an object or a word that has a weight of 0.8 in the dimension of dog, 0.7 in the dimension of eat, 0.01 in the dimension of joke, so depending on how often the word cat occurs with all these words, okay, and this I can do for different words, and then I can capture how similar they are. And this is a very powerful technique, although it looks very simple. It works quite well in many applications that we will see. So now let's take an example, and how do we start constructing this vector space or word space model, and try to see can we compute the similarity across words. So here I am given a small data set that has 6 different sentences, and so like an automobile is a wheeled motor vehicle used for transporting passengers and so on. There are 6 different sentences are given, and I have to build a vector space model or a distribution semantic model. Now to build the model, I need to start with what are the words I want to represent, and these are my target words. So here I want to represent 4 words: automobile, car, soccer and football. So now once I know what are the words I want to represent, the next question I need to ask is, I need to represent in what dimensions. So this becomes my context, here also denoted by term vocabulary. What are the dimensions in which I will be denoting all these 4 words? So here I have 1, 2, 3, 4, 5, 6, 7 dimensions. Now, so what will be the informal algorithm for constructing the distribution semantic space or the word space? You start by picking up the words that you are interested in. That means the words for which you want to find the distributions, and these are called your target words. So here I start with 4 target words. Then you define what are your context words also. So here you found 7 context words. Next question would be, okay, when do I say that this word occurs with another word? Should I say that when it occurs in the same sentence, same paragraph, same document, or within plus minus 2 words? Okay, when do I say that? So that is called the context window. So I can define my context window to be maybe 5 words around the word, or it can be a sentence, paragraph, or whatever I want. So I need to define a context window, that is how many words should I consider surrounding a target word, and it can be defined in terms of the document, paragraph, sentences, and so on. Now a simple method would be, once you have defined the context window, you know what are your target words, what are your context words. So when you are defining distributions of the target words, find out how often they occur with the various context words within the context window, and just write down the number. This occurs with this word in this context window 2 times, 3 times, 0 times, and so on. And you define the vectors for different target words. And this can also be called as your co-occurrence matrix between the target words and the context words. Now once you have built the co-occurrence matrix, you can think of each row of this matrix as your vector that denotes each individual word. So if we try to apply this algorithm on the previous example that we have seen, so what we will have 4 words as the target words, 7 words as my context words, and I'll have a matrix of dimension 4 cross 7, and each element will denote how often this target word occurred with this context word within my context window. Let us say the whole sentence here is the context window. So you can try doing that with the example that we had seen, and try to find out what are the different number of times each individual word occurs with another word, and you will find something like that. So this you can call as your co-occurrence matrix or distributional matrix, composed of targets and contexts. So what do we see here? Automobile occurs with wheel, transport, passenger. Football occurs with passenger, tournament, London, goal, and match, and similarly for car and soccer. So now this is my representation of target words in this semantic space. Now suppose I take only 2 dimensions of the semantic space. So here I had 1, 2, 3, 4, 5, 6, 7 dimensions. Suppose I see only 2 dimensions. So here I am seeing goal and transport, and I am projecting all the 4 words in these dimensions. So what representation I will see? So I will see that soccer occurs with goal and goal, not with transport. Football occurs with goal, not with transport. Automobile occurs with transport, not with goal, and car occurs with transport, not with goal. Immediately you can see some separation, that is the soccer and football are coming out to be more similar. Automobile and car are coming out to be excuse me, are to be more similar by just looking at these 2 dimensions. Okay, and that is some very interesting aspect that the distributional semantic models try to capture. Now suppose I go back to my vector representation, so where I have all the 7 dimensions, and I want to find out which 2 words are similar and to what degree. So one simple thing I can do is to take the dot products. Okay, so that will tell me if they are having weights in similar dimensions. If they are having weights in different dimensions, their dot products will be 0 or close to 0. But if they are having weights in same dimensions, their dot product will be high. So suppose we are not doing any normalization, I can just take simple dot products and find out which 2 objects or which 2 words are more similar than other words. So if you try to do that in this example, so what would you find? Automobile and car. So dot product would be 1 plus 2 3 plus 1 4, and everything else is 0. Similarly, automobile soccer you will find 0, automobile football 1, car soccer 1, car football 2, and soccer football 5. Okay, so from these simple dot product computations, so what is something that you see? So you see that immediately you can capture the idea that here automobile and car are very similar. They are having a very high dot product, 4. Similarly, soccer and football are also very similar. They are having a dot product of 5. On the other hand, automobile soccer are not much similar. Car and soccer are not much similar, and so on. So you can find out some sort of differential aspect of my meaning, that is which two words have similar meanings and which two words have different meanings, just by looking at this simple distribution. And as you keep on getting more and more data, you will be able to capture more and more information about how similar and how different two meanings of words are. Now this is a very basic idea that I had tried to give in this lecture. Now we will see what are the different formal ways in which we can construct these models. How do we count? What are the different ways in which we can denote the entries of this matrix, and how do we use that to compute similarity across two different words? Okay, so this we will cover in more detail in the next lecture, but I hope that the main idea of using these distributional models is clear.